Hello everyone, I'm going to give a brief presentation of my project, a visual memory degradation rate based on different image features. I'm hetongli from Computer Science and Information Department of University of Florida. So, why I choose this project? Although human long-term visual memory can store a large amount of visual information, it tends to degrade over time. And recent works have shown that image memorability is an intrinsic property of an image that can be reliably estimated using state-of-the-art image features and machine learning algorithms. However, the class of features and image information that is forgotten has not been explored yet. So I choose to do this project based on the previous research. This project introduces a probabilistic framework that could generate the memorability map of an image through different features and predict the most memorable and forgettable area of the image. The related work for the project is image memorability. A large number of recent works on image memorability have shown that there are large differences between the memorability of different images, and these differences are consistent across contexts and observers. And this phenomenon suggests that the memory differences are intrinsic to the image themselves. The dynamic scenes with people interacting are most memorable, and static indoor environments and human-scale objects are somewhat less memorable, and outdoor vistas are forgettable. Okay, so next is a system implementation part. First, I want to say is about image representation transfer. The left image here is the original image that was captured by observer, while the right one here is the internal representation of image in memory after noise processing. As is shown in the picture, the people and car in the green and blue frames keep unchanged in the conversion process, but the object in the red frame becomes blurry and something was added to the internal representation as shown in purple area. So we can see that the people and object near them were remembered most clearly, but other objects in the background were easy to forget. Thus, the degrading rate for these objects are variant. The degrading process of memory can be represented by an image vector in the model with missing and changed information. Thus, the most important theory of the project algorithm is that the further the internal representation is away from its external representation, the most likely that it will be forgotten and hallucinated. Thus, some conception here should be introduced. The first ij represents the image J, and RE is the external representation of an image. RI is the internal representation. And here is the image type, and the beta array 0, 1 here record the regions in the image, while 1 means that the type exists in image and 0 means the type doesn't exist. And the next part is the image transfer. I use two vectors here, fnj to represent the forget and hallucinated rate for image. The observer's reaction for transformation the image could be represented as following two situations. If the observer forgot the existing objects in the original region whose REI equals to 1, the RI will equal to 0 and generate a hit miss like this. And if the observer hallucinated the information in region I and generates a new object that doesn't exist in the original image, the RI will equals to 1. So having got the previous conception, we could calculate the distance between the internal and external representation. I define the distance between the two representations as dj equals to the rej and rij. There's an inverse ratio relationship between dj and the memorability of image j. This is higher, so we can see that the higher the expected distance of set of image j is, the higher the image j will be forgot or hallucinated by observer. So for all the image, the expected distance could be calculated as follow here. The n here is the number of images totally, and the formulation shows that the result of the experiment will demonstrate the memorability rank of different type of image. Considering the region type, I choose this for image texture, gradient, shape, and color. Why I choose this for is that I researched the related field of the memorability maps, and I found that these four are the most representative features as far as I'm concerned. Thus, I choose these four features for region type calculation. This picture shows the process of memory map generation. The original picture is segmented into three parts, which have people, related objects in the background, and background. For each of the three regions, there should be four memorability maps. I used gradient, color, and texture to demonstrate the process. We can see that each feature forms its own memorability map, like this. And after getting these three memorability maps, I added some weight on them to formulate the final memorability map here. This part is the evaluation part. So the memorability map of the image is a result of combining the four feature memorability maps together, as we can see here, 1, 2, 3, 4, and combine it as the final memorability map here. This one has a memory score of 0.87, and this is 0.61, and this is 0.24. After we have gotten the memorability map, we can calculate the region type, as we see here. For each image feature, I statistic the memorability score of the original image and the vector f value the algorithm calculated. The square in the image is a specific region the algorithm calculated. I use color square to represent the specific region type. The warmer the color is, the higher the memorability score, while the cooler the square is, the lower the memorability score is. We can get from this that the value of f is opposite to the memorability score, which is which is the same as I proposed in the proposal. So next part is the standard deviation of variable f. To evaluate the overall performance of the region types, I calculated the standard deviation for each image feature type's memorability scores and draw them together for comparison. As is shown in the picture, I use 4 lines with different colors to demonstrate the different memorability scores for each image feature. For each region type, I calculated their average memorability score and ranked them by f value. We can get the result from the picture that f between 0.4 and 0.6 perform a high standard deviation, which means that these images perform uneven on memorability score, this part, and are hard to make prediction than other images. This suggests that the algorithm is effective at learning the regions with high and low probability of being forgotten, as proposed in the framework. Okay, that's all. Thank you.